All right, in this video, we're going to be going over Unit 2, Lesson 1, which is two-step inequalities. This is part of our Pre-Algebra Equations and Inequalities unit. And the benchmark here is MA 8.AR.2.1, which is solve multi-step linear equations in one variable with rational number coefficients. All right, so we need to solve two-step linear inequalities in one variable and represent solutions algebraically and graphically. So this is AR 2.2. This is a copy of the guided notes that students will be completing in class, and then this is a copy of the practice that students will be doing and completing on the paper to show their work, and then it will be submitted in Canvas for the grade. All right. So to solve two-step inequalities, first of all, we need to know what an inequality is, and that is just a comparison between values that involve one of the following symbols. So we have our greater than symbol, our less than symbol, greater than or equal to symbol, and the less than or equal to symbol. So when we are graphing an inequality, we can graph a one variable inequality on a number line. For example, if x is greater than 2, to put that on a number line, we would do an open circle because it's just a greater than symbol. Notice open circles are used for greater than or less than symbols. Closed circles are for greater than or equal to or less than or equal to. The key difference between these is the equal part underneath the symbol. So we are going to graph x is greater than 2 on the number line. So here's our number line. We're going to go to 2. We're going to place our open circle. And when we have a greater than symbol, we're looking for numbers that are greater than 2. So we're going to go to the right. These values to the right of 2 would be our possible solutions. So the solution begins at 2 with an open circle, and the solutions are to the right. If we are going to graph x is less than or equal to negative 2, well, sorry, that's slightly out of order. That's okay. Less than, x is less than, that's what that means. The symbol means less than or equal to negative 2 on the number line. So here is negative 2 on our number line. Now we would have a closed circle, and because it's less than, we are going to go to the left. So that means that for this inequality, that our solution begins at negative 2 with a closed circle, and the solutions are to the left because it's less than. All right, so if we're looking at these greater than, less than, greater than or equal to, or less than or equal to, graph these four inequalities, try them on your own, check with your partner, or try them on your own, pause the video, and come back and check to see if you got them right. So we have x is greater than or equal to 0. So here's our greater than symbol, equal. Okay, we're going to start at 0, and we should have a closed circle. And because it's greater than, we are going to go to the right because we are looking for the numbers that are more than or greater than 0. Here we have x is less than 4. So now we're going to have an open circle at 4 on our number line. And because it's a less than symbol, we're going to go to the left. Then we have x is greater than negative 4. So we're going to go to our number line at negative 4. There is no equal sign here, so we would have an open circle. And we are going to go to the right. Because it's greater than, we're going to the right. Finally, we have x is less than or equal to negative 1. And so we're going to go to negative 1 with a closed circle. And with a less than symbol, we are going to go to the left. Check your answers. If you got them right, great. If not, go back and check them so you have the correct answers in your notes. All right, so now we're going to solve an inequality. To solve an inequality, we want to isolate the variable or get the variable by itself. So, for example, we have 3x minus 8 is less than 16. Our first step is going to be to add or subtract the constant. So if I'm looking at these terms, the constant is the negative 8. Okay, so we're going to add 8 to both sides of our inequality because we want to get this variable here by itself. So if I add 8 to negative 8, it's going to become 0. So that means 3x is by itself. Almost. Well, the 3x is by itself. So now we have 3x is less than 24. The x is still not isolated or by itself. This 3, the coefficient, is being multiplied to the x. So the opposite or inverse of multiplication is division. So we have to divide both sides of our inequality by 3. When I divide 24 by 3, I get x is less than 8. Now I have an inequality that I can put on a number line. So we're going to go to 8 on our number line. We should have an open circle. And because it's less than, my arrow should be pointing to the left because I'm looking for all of the values that are less than 8. So there is one thing to remember. If you multiply or divide by a negative number, we do need to reverse the inequality. So what does it mean to reverse the inequality? Let's see what happens. So we have negative 2x plus 5 is greater than or equal to 19. So first thing we're going to do, just like we did before, was move the constant. We have to add or subtract the constant, the number without the variable. So we subtract 5 from both sides. Negative 2x is greater than 14. Then we have to divide by the negative 2 because that's a coefficient. So in order to remove a coefficient, we have to either multiply or divide to move the coefficient away from the variable. So when I divide by negative 2 on both sides, then I get x is now going to be less than or equal to negative 7. See how I went from greater than or equal to less than or equal to? That's because I divided by a negative number, and so I had to flip the sign. So if I have negative x over 4, which is actually a negative x being divided by 4, minus 2 is less than 4, my first step is going to be to add 2 because that's the constant, and I want to move the constant away from the variable. So I add 2 to both sides. I get negative x over 4, or negative x being divided by 4, is less than 6. So to get rid of this negative and the 4, because it's being divided, x is being divided by 4, I'm going to multiply by negative 4. And I do that on both sides. And so x is less than negative 24. Oh, wait, I flipped the sign. That's because I multiplied or divided by a negative number, so I had to flip the sign. So x is actually going to be greater than negative 24. Now, why do I have to flip the sign? Because if I have 2, and we know that 2 is less than 4, what happens when I multiply both sides of that inequality by negative 1? Well, then that's going to become negative 2, and that would become negative 4. Well, is negative 2 less than negative 4? No, that is not true. So because of this, because of what happens when you multiply by a negative, that's why we have to flip the sign. All right, we're going to do two examples here. We have 3 being multiplied in the parentheses times x minus 2 is less than 18. There is a question like this on the test, so I would make a special note about this on how to solve it. So we have 3 being multiplied by a parentheses here is less than 18. Well, if this 3 is being multiplied times the parentheses, what we want to do is get rid of that 3 or move it away from the parentheses first. So we divide both sides by 3. When we divide by 3, the parentheses goes away and we're just left with x minus 2. 18 divided by 3 is then 6. At this time, I have not changed my inequality sign. My next step is to move this constant. To move or get rid of a constant, I have to add or subtract. So this is x minus 2, so I'm going to add 2 to both sides. And so x will be less than 8. Then I'm going to come down here to my number line and label my number line. I'm going to have an open circle because there's not the equal sign there, it's just a less than symbol. And my arrow should be pointing to the left because I'm looking for the values of x that are less than, so below 8. All right, one more example. We have negative 0. You can also check your answer, but I want to move on to this next example, number 2. So we have negative 0.5x minus 5 is less than or equal to 15. So the first thing we're going to do is move our constant. So we have to add 5 to both sides. Once we add 5 to both sides so that this on this side of the inequality becomes 0, we add 15 plus 5 and we get 20. So we have negative 0.5x is less than or equal to 20. Then we have to get rid of the coefficient, and to get rid of a coefficient, the number in front of the x, we have to divide to get rid of the coefficient. So divide by negative 0.5 on both sides. When I divide by a negative, I have to flip my sign. So x is now going to be greater than or equal to negative 40. So here on my number line, I can label my number line however I want, but I do have to make sure my numbers are going in the correct order. So I have negative 40. I'm going to have a closed circle, and my arrow will be going to the right. Then I can check my solutions by plugging in negative 40 and making sure that it's true. Is 15 less than or equal to 15? Yes. Is negative 39 when I plug that value in, which is this first number after the closed circle? If I plug that in, is that solution also true? Yes, it was. All right, that's it for your two-step inequality notes.